All right, everyone, welcome back to the land of Chem. I'm your host and the author. My name is Jeffrey Drum. Thank you all so much for joining me again.
All right, everyone, welcome back. Now, the moment you all have been waiting for, the culmination of more than a decade of research and hundreds of hours of on-site investigation on the Giza Plateau, the full function of the Great Pyramid finally revealed, including all mechanisms of operation, chemical reactions, and brand new animations illustrating the entire reaction sequence. Ladies and gentlemen, as always, thank you all so much for the support. I think that's it for today's intro, so without further ado, let's get right to it. Now, to begin, I will be doing a comprehensive breakdown of every single aspect involved in the function of the Great Pyramid that produced the chemical reaction generating the final dilute sulfuric acid product solution, exactly like was just completed regarding the detailed examination of the mechanisms of operation within the Red Pyramid in episode 156, 157, 158, and 159. So let's start with step 1, the external reservoir. In episode 161, I established the legacy of this ancient hydro-technology, dating back to proto-pyramids like Silbury Hill that utilized water to facilitate exothermic chemical reactions, and stone circle systems like Avebury and Stonehenge, where the external reservoir was part of the telluric current concentration mechanisms that elicited lightning strikes on the central obelisk menhir stones. And this physics and chemistry-based technology was taken to its pinnacle execution in Egypt, and the external reservoirs remained an integral part of each pyramid system, from the Bent Pyramid to the Great Pyramid, providing the water for both driving the physics of the internal reaction chambers and as a reactant for producing the chemical reactions, with each reservoir specifically designed for the exact sequence that was occurring inside of each structure. So now let's focus with the external reservoir of the Great Pyramid, which you can see here, filled with water. And there is only one component of the Great Pyramid system that is connected to this external reservoir, which is the descending passage, leading down into the subterranean chamber. So this directly implies that these three features are functionally integrated. Here you can see a diagram showing the configuration of the subterranean chamber with the northern descending pump shaft here, the well shaft here, the compression chamber here, a pit leading down into the bedrock here, and a dead end shaft, this southern shaft that terminates into the bedrock. And my hypothesis is that the water from the external reservoir flowed down the descending passage, filling the subterranean compression chamber, like you can see here. This theory was also corroborated by John Cadman, who proposed that these components were a part of a ram pump system that is depicted in this diagram. However, there is one major issue with this theory, that this chamber was utilized to pump water out of the Great Pyramid in this direction. That major issue being that this bedrock excavated shaft is a complete dead end. There is no check valve, there is no output line, just solid bedrock. And I have personally explored this southern shaft during private special permission access into the Great Pyramid, and I will put in a quick clip now so you can see conclusive evidence proving that this shaft is a complete dead end. It does not go anywhere, which completely falsifies Cadman's well-known theory about the subterranean chamber, that it was a ram pump or water hammer to pump water out of the Great Pyramid. Check this out.
All right, and you can see somebody's little piss jug here.
Yep.
All right.
So we just got to prepare to go coordinated backward. Everybody good with that?
Yeah.
You are.
Yeah.
All right. So I can tell you for sure, just looking at it, that this is a dead end.
Yeah.
100%.
Jumpy, can you check the walls around us?
Yep. So I do see a bunch of salt down in here.
Loads of it.
Yeah, lots of it.
But yes, that is as dead end as it gets.
That's it?
That's it.
Yeah.
That's not very far.
No, it's not very far.
So the idea that this was a ram pump and that water was being pumped out of the structure through this area, well, we just disproved that, right?
Yeah.
Because this doesn't go anywhere, that's bedrock. So if water was in this chamber, it only had one way to go, which is up through the well shaft into the rest of the structure. And I think we can all kind of pivot. If you want to come further, hey Lex, see if you can turn around.
I don't think I can.
So then just go backwards. If you can't turn around,
Here, babe. Take the camera. You can get the termination.
Just turn around now.
so the ladies and gentlemen at home can see this for yourself, that we're not just saying that. This is the end, the dead end of the shaft.
What's this fissure, Jeffrey? What do you think?
Hold on, let me turn around and I can see it.
All
Oh
right.
my God, there's plenty of salt around this.
Ton of salt on the ceiling.
Yeah.
Okay. There you go.
Oh, yeah. There looks like there is enough space to turn around up there.
Well, so not much here. No, I can barely turn around. So just go backwards.
Okay. What do you like? There's this really prominent fissure right here.
All right, let me take a look.
Here we go.
Yeah, I was just trying to point this out. So like right here.
Okay.
Oh, okay. Yeah.
So it may be
Yeah,
a
like-
natural fissure in the bedrock. I see one here as well. Looks like there's some iron oxide in here.
Yeah. Check this one out. Check this.
Yeah, so that does look like just a natural fissure. And I do see some iron oxide in here.
Yeah.
So very similar to what we saw on the way down in the shaft,
Yeah.
just a much smaller vein.
Cool.
Some garbage.
How you doing?
Huh?
How you doing?
I'm good. Hot up in here. Okay. You're fine. Take the video.
Okay. So it's locked.
So again, imagine you're the poor Egyptian guy
Sorry.
that they sent to go explore this thing with no flashlight. Go, babe. Okay. Okay. All right.
Okay. So we know the water wasn't going out through where we just were. So the water could only go down or up. So let's say instead of the pump block coming down the descending shaft, what if it went the opposite way and it was like the back of a syringe that pulled water up through this from a subterranean aquifer, pulled water into the system, and then all you need is a two-way valve. So when you're pulling in this way, the valve opens in this direction, allowing water into the chamber, and then when the block moves in the other direction, the valve is pushed down and the water is pushed up into the upper chambers.
And then what would be the purpose of that? Just for overflow or something?
So I believe that this, and I agree with Cadman, that there is compression, fluid compression in this shaft that assists in pushing water back out in this direction.
Right, it'll go back, hit the ground.
Because he showed in his experiments that the fluid pushes back out into this direction as well. So whenever you guys are ready,
Yep.
we'll head back up the shaft, and then we'll go next to the Queen's chamber.
All right, now that you've seen video evidence of this complete dead end in the bedrock, what Cadman is proposing here is 100% impossible. There is absolutely no way that the water could be pumped out in this direction. One area where I do agree with this hypothesis is that the primary source of the water is from the filled external reservoir, which you can see here. But after the water enters the subterranean compression chamber, there is only one place that it can go, and that is up through the well shaft into the reaction chamber system. Now, the next feature that I'll bring to your attention is a system of one-way valves in this subterranean pump chamber. And I am not the only one who has proposed this idea either. What you are about to see is a fantastic animation by a German engineering team that I found when I was preparing way back for episode 24 that shows a similar idea of the one-way valves within the Great Pyramid that I proposed in my book, like the one-way valve that you can see here from this animation. Another interesting similarity between this German engineering team and my hypothesis is the utilization of a, quote, pump mechanism within the descending shaft. With that being said, there are also some tremendous differences between their work and mine. For example, the configuration of said pump mechanism. They also envision a shaft that circumvents the blocked ascending passage, which simply does not exist, when the well shaft would serve the exact same purpose. And I highly disagree with the final stage of their theory, as they completely ignore the presence of the 3 granite slabs within the antechamber that would prevent the king's chamber from filling with water. But this animation does demonstrate the main concept of my hypothesis, which is filling the internal reaction chamber, specifically the Grand Gallery, with water from the subterranean compression pump system. And although I disagree with most of the details about this theory, The animation does an exceptional job of illustrating some concepts that will come into play shortly. Now, the original video is in German, but I'll do a voiceover translation so you can hear their explanation. Check this out. I'll start now. First, with the narrow passage.
Hat das Wasserhebewerk in zwei Abschnitte unterteilt.
Herman divided the water pumping station into two sections, a lower stage and an upper
Durch einen
stage.
unterirdischen Kanal gelangt das Nilwasser in
The
die
low
Felsen.
water reaches the rock chamber about 30 meters below the pyramid base through an underground channel.
Einen Rückfluss des
To
angesaugten
prevent the
Wassers in
sucked
den
in
unterirdischen
water from
Kanal
flowing
zu
back into
verhindern,
the underground
ist der
channel,
Brunnenschacht
the
mit
well
einem
shaft is
Ventil
equipped
versehen.
with a valve.
Hat
Once
das
the rising water
diese Kammer bis
has
zu einem bestimmten Punkt gefüllt,
filled this chamber
kann die
to a
Luft
certain
nicht mehr aus
point,
ihr
the
entweichen.
air can no longer escape.
Also bildet sich an der Decke ein
This means that an air cushion forms on the ceiling, which is crucial for the pumping process.
Das Wasser
The water
strömt
continues
weiter
to
in die
flow
Hauptzylinder
into the main cylinder of the lower stage.
Es steigt in diesem Gang auf.
It rises in this passage until the piston inside is completely submerged in water and the actual pumping process can begin.
Über ein Zugseil wird der Kolben rhythmisch
The
auf
piston is moved rhythmically up and down using a pull rope, causing the water to vibrate.
das Luftpolster in der Felsenkammer.
The air cushion in the
dient
rock
Wasser
chamber
hierbei als
acts
Federung.
as a spring
Auch
for
der
the water.
Kolben verfügt über ein
The
Ventil.
piston also has a valve.
Dieses öffnet sich bei einer
This
Abwärtsbewegung
opens when the
des
piston
Kolbens
moves
und
downward
lässt das Wasser
and
hindurch.
allows the water to flow
Bei einer
through.
Aufwärtsbewegung
When it moves
schließt
upward,
sich das Ventil und
the
der
valve
Kolben saugt
closes
Wasser
and the
an.
piston sucks in water.
So wird das Wasser
This way, the
durch die
water is
Kraft
pumped
mehrerer
upwards by
Männer
the
in
strength
die
of
Höhe
several men.
über 100 Meter. Durch eine schmale Verbindungsleitung gelangt das Wasser in den
The
Hauptzylinder
water
der
reaches the
Oberstufe.
main cylinder of the upper stage over 100 meters through a narrow connecting pipe. Here, too, a valve prevents the backflow into the cylinder. The cylinder has been filled with water up to a certain height. A second team sets the piston of the upper stage in motion. You can estimate the second piston in motion. At the same time, the so-called gallery begins to move, a sloping water basin with around 1,000 cubic meters. In the upper stage, the water also begins to vibrate rhythmically against an air cushion. This is located in the Queen's chamber. With another piston, the water is pumped into the large gallery, which serves as a kind of water reservoir. Once the large gallery is completely filled, the water flows into the uppermost chamber of the pyramid, the king's chamber. The so-called sarcophagus was probably a water carrier for cleaning work, but it could have also served as a support for the cable deflections of the pulling mechanism that were necessary in this area. Since there also air accumulates in the king's chamber, water can only flow upward through two narrow channels, the soul shafts. All right, now that you can visualize the concept of the one-way valve system, a pump mechanism, and the internal chamber filling process, there is one important takeaway from analyzing these two theories, which is that multiple independent researchers from around the world who have never had any direct contact have all arrived at similar conclusions regarding the descending shaft and subterranean chamber system, that it is a type of water pump. And although the mechanisms of operation and the ultimate goal of this process differ, the concept remains the same. In my opinion, this is a solid indication that there is some truth to the idea that the external reservoir, descending shaft, subterranean chamber, and well shaft are a part of the Great Pyramid pump system. And as applied to my theory, it is the first stage of operation involved in the sulfuric acid chemical manufacturing process. So now I'll explain how I think the system works, starting with this diagram of the Great Pyramid, so we can get a good view looking from east to west of all the internal working components. The external reservoir is filled with water, which then fills the pump shaft and the subterranean compression chamber and the well shaft, equal to a level of the height of the water within the external reservoir. In this stage, the compression chamber one-way valve is closed here, and the well shaft grotto one-way valve here is open, and this southern shaft is a complete dead end. The water only has one place to go, which is up. Now, the pump mechanism is activated, driving the water down the pump shaft, and the pressure within the dead end compression chamber system force the water back up the well shaft in this direction, which begins to fill the upper reaction chambers. And as I was discussing with my group during the tour, the conventional names for these components contain vital information about their functions. For example, the offering chapels of the Eastern temples being used to offer or introduce reactants or water into the system. And here, inside of the Great Pyramid, we have the exact same thing with this quote-unquote well shaft. So what is a well? It is literally a water supply, and that is exactly the function of this component, to supply water into the upper reaction chambers. The pump mechanism procedure can then be reactivated until enough water has been pumped from the compression chamber up into the grand gallery until it has been filled to maximum capacity, as you'll see in my animation in just a moment. Here you can see the grand gallery, again filled to maximum capacity at this level. So when the pumping stops pushing water up the well shaft, the pressure from above will close the one-way valve in the grotto, thus maintaining the water level in the reaction system. The chemical reaction sequence is then activated, and I'm leaving out the water draining process as explained in episode 80, which occurs from the extraction chamber for brevity, and the reaction proceeds to produce sulfuric acid solution, which is then removed from the structure through the extraction chamber shaft. Don't worry, this reaction sequence will all be explained in depth, step by step, in the subsequent installments of this series. The pump mechanism can then be pulled back up the northern shaft, much like the plunger of a syringe, and very similar to the concept presented by the German engineering team, which would then open this one-way valve here and allow water to be pulled back up the pump shaft, as you can see here, filling the pump system back up, and then it can be run continuously via the exact same procedure, all while leaving the water maintained within the external reservoir, which is critical and will be explained in a later episode, as there is a secondary function for this external reservoir system. Now, a quick side note regarding the source of the water. Let's say that there is a subterranean aquifer, or just the water table below the Great Pyramid. The syringe and pump method could be used when that water table was full during the flood season. But when the water level lowered, and thus the water table below the structure, the external reservoir could be used to supplement that subterranean water source, ensuring continued operation, so that regardless of fluctuations of underground water levels, the system could always be supplied from the external reservoir. All right, now let's jump into a more animated sequence of steps without explanation, so you can just see the system in operation. Let's go. All right, everyone. I hope you're enjoying the video. And if you want to help support the channel, you can pick up a copy of the book and grab some merch at thelandofchem.com. The second edition Egyptian Blue version is now back in stock, Same text as the first edition, just a new color design, and a brand new merch drop. Inazuma Kagaku, lightning, chemistry. Absolutely gorgeous kanji calligraphy designed by my Japanese tattoo artist Shin at Funky Guns in Kobe, and all of your favorites, including stickers. Links to everything in the video description below. Thank you all so much for the support. Now, back to the video. And let's go back to episode 74, Ancient Egyptian Sulfur Mining, where I established the precedent of the extraction of native sulfur deposits in Egypt and the utilization of this potent yellow element for various applications, with the first documented evidence coming from, of course, the dynastic period, as stated here in this article, that the history of sulfur can be traced back to the Egyptians, with an interesting note here that sulfur is the primary source to produce, of course, sulfuric acid, the world's most used chemical and versatile mineral acid, and is used in many processes in the chemical and manufacturing industries. Sulfuric acid is used by the fertilizer industry to manufacture phosphate fertilizers, which are vital to agriculture and ensuring healthy, high nutrient value crops. So this substance is not only used industrially for applications like leach mining, but can also be employed in producing agricultural fertilizers. As always, with the technology of this ancient civilization, it always goes back to providing the most important resource for the people, food. And a few interesting notes here. The ancient Egyptians used sulfur for a variety of purposes, including religious ceremonies, medicine, and bleaching. Regarding the sources of sulfur, it mentions here these native deposits. Egyptians likely obtained sulfur from naturally occurring deposits, particularly in volcanic regions. And here they also mention the heating of pyrites. Sulfur may also have been derived from heating iron or copper pyrites, according to Georgia Gulf sulfur. And here, regarding the mining techniques, they mention surface mining, stating that early sulfur mining likely involved finding and harvesting sulfur on the Earth's surface. I found it interesting that they also mention here the Frasch process, as you will see in just a moment. This process, which involves melting sulfur underground and pumping it to the surface, was not developed until later, this being the modern process by which sulfur is extracted from bedrock deposits. And a few interesting notes here in this article entitled On the Origin of Native Sulfur Deposits in Gebel El Zayt in the Gulf of Suez in Egypt, stating that elemental sulfur deposits occur in this region in various locations, rock types, and forms, which corroborates the fact that there is an abundance of sulfur deposits in well-known mining areas of Egypt, like Gebel El Zayt, which I have also discussed extensively in previous episodes regarding the mining and metallurgy operations of the ancient Egyptians, specifically galena mining, which is known to have occurred in this region. I also found it interesting that my Google search also mentioned the Frasch process, as I had suggested in episode 74 that the ancient Egyptians may have been using a similar process to this modern-day mining technique, where compressed air and heated water are pumped into the bedrock for the extraction of subterranean sulfur deposits. During this same episode, I also laid the foundation for the concept of the integration of abundant natural resources in Egypt as primary reactants within the pyramid chemical engineering technology. For example, sulfur, air, water, and natural gas methane being converted into syngases like sulfur trioxide, hydrogen, and nitrogen that were then utilized for the synthesis of final products like sulfuric acid and ammonia, substantiating my hypotheses for the functions of structures like the step pyramid, for the extraction of bedrock natural gas methane deposits, the production of hydrogen from water within the Serapeum, the conversion of hydrogen and nitrogen within the red pyramid to create ammonia, and the transformation of sulfur trioxide into the final sulfuric acid product within the Great Pyramid. And yes, these two final products, sulfuric acid and ammonia, can be combined to create ammonium sulfate in a very simple process shown here on a laboratory scale, producing another valuable fertilizer compound. And if you haven't seen it yet, I'll put a link to episode 74 in the video description below. Now, when I dive back into the archives of the Land of Chem episode vault for videos like this, I am always absolutely staggered by how prolific the research is that has been presented here on the channel. This is such a passion for me that during the process of making these hundreds of episodes, I never really realized how all of it accumulated into such a massive amount of evidence until I look back at some of these early groundwork videos from several years ago. I am so proud of the work that has been done here to establish the scientific viability of these hypotheses. And by constantly pursuing more knowledge and understanding of how these systems worked, it has led me to colossal breakthroughs like what you are about to see. Perhaps the most important revelation regarding the Giza Plateau and the function of the Great Pyramid that I have ever discovered. All right, so before we get to the source of the sulfur, let's start with a critical component of the sulfur furnace chamber that I haven't presented thus far, the sulfur dioxide inlet shaft, which is located in the northwestern corner of the chamber, as shown here in these original plates from John Perring. Magnified here, looking from the south to the north, you can see a shaft below the king's chamber here. And again, from this plate, shown in this direction from the east to the west, with this shaft below the floor of the chamber. Highlighted on this diagram with this larger excavation by Howard Weiss, expanding the shaft and excavating to a depth of 4.2 meters. A critical and often overlooked detail about this shaft is that it was already there before the modern explorations by both Perring and Weiss, as noted in the section of Perring's book describing the condition of the chamber prior to their investigation. And I will quote here, "One of the blocks composing the pavement had been taken up near the northwestern corner of the king's chamber, and an excavation had been carried on beneath the sarcophagus. This last, however, was almost entirely filled up with rubbish. So not only did this shaft already exist before it was later excavated and expanded by Weiss, but it was completely backfilled and covered up before any modern entry into the chamber. And just as I proposed regarding the original floor and the location of the extraction shaft within the final chamber of the Red Pyramid, there was something compelling about this area of the sulfur furnace chamber floor that justified these ancient explorers to dig further into the structure, following an inlet shaft down below the chamber. Unfortunately, this area of the chamber is now completely covered by a steel plate, but you can see it here. This hole in some of the original photos, and the fragment of red granite that was removed from this area of the chamber floor when the excavation was expanded. Here is another large piece of the granite that was removed from the floor area. And both of these fragments can be seen here in this picture. Guessing by the quality of the image is from the 80s or the 90s. And you can see here the flimsy grate that once covered up this shaft in the corner of the chamber. But somehow, this massive slab of granite and the smaller chunk here have now mysteriously disappeared from the chamber, and this is what it looks like today. This is a modern steel plate that now covers up the hole, with all of the original documentation stating that this shaft, shown in the diagram, was discovered already backfilled with debris and rubble, and no further excavations were pursued. And courtesy of Matt from Ancient Architects in his video entitled, "What's Below the Floor of the Great Pyramid King's Chamber?" Link in the video description below. We can actually see below the grate, with the modern brick wall covering up half of the opening here, basically creating a partition between the elongated excavation area, and some images looking down into the pit, again completely filled with sand, debris, and this modern concrete and brickwork over here holding up this wooden post. In my opinion, there was absolutely something down in this shaft, but it was of no interest to the original explorers, as there was zero treasure or pharaonic burial items. It was just a hole that continued down below the floor of the king's chamber that was already filled in by millennia of dirt and sand, so the unassuming, innocuous shaft was covered up, as at the time it was explored, there was no concept of it being a potential functional component of the chamber. It was just a hole in the ground that explorers predating Pairing Advice had already attempted to investigate. And in this diagram, you can see that this floor block and this chunk could be moved back into place here and here, filling the areas of the floor that were removed by Weiss during his excavations, but the original shaft inlet remains exposed. There were no floor stones covering this opening. This is the location of the inlet shaft that was utilized to introduce sulfur dioxide gas into the furnace chamber. So now, where did the gas come from? Let's go back to episode 153 regarding the synthetic aperture radar scans, where I showed evidence of the cave and tunnel systems running below the bedrock of the Giza Plateau and the formation thereof, technically known as hypogene speleogenesis, or cave formation from below the surface of the earth, specifically sulfuric acid speleogenesis, which is cave formation as a result of sulfuric acid. And I presented these images of hypogenic cave systems with formations that look exactly like what we have discovered all over the Giza Plateau, as you can see here from the bedrock on the east side of the Great Pyramid, and here from inside the Tomb of the Birds. Furthermore, it has been established that these hypogenic caves are in fact iron ore caves, the discovery of which are directly associated with ancient mining activity on the Giza Plateau, and these tunnel and cave systems can extend for hundreds of meters below surface level. Another example here showing a hypogenic iron ore cave that looks exactly like the inside of the Tomb of the Birds, and these systems can form in a variety of configurations with vertical features, isolated chambers, single-level networks, and multi-level subsurface complexes with isolated and extended caves connected via horizontal and vertical shaft systems. And upon further investigation of the underground system below Giza, I discovered perhaps the most important research paper that has ever been written about the Giza Plateau itself, entitled "On the Development of Sulfuric Acid Speleogenetic Deposits Within Cavernous Middle Eocene Beds, an Inference on Hydrocarbon Gas Seepages, Giza Pyramids Plateau, Egypt." I know this is a complicated title, so I will break this whole thing down. Basically, the paper is evaluating the formation of mineral deposits within cave systems that are formed by sulfuric acid located below the pyramids on the Giza Plateau that are directly connected to hydrocarbon gas seeps. Does any of this sound familiar? At this point, I hope you're realizing the importance of the foundational research leading up to this episode and how it's all coming together. I have been teasing this release for quite some time and have said since day one that the Egyptian pyramids were designed to operate in conjunction with the forces of nature, and the location for the construction of the Giza Plateau chemical and mining operation was strategically selected for the exploitation of natural resources that would fuel these systems. So now, let's dive a bit deeper into the paper itself to see what they have revealed, and I'll quote directly from the abstract here. The development of sulfuric acid speleogenetic mineral deposits within cavernous Middle Eocene beds of the Pyramids Plateau is linked to hydrocarbon gas seepages. The morphological and petrographic features and chemical composition of the studied mineral deposits reveals a hypogene sulfuric acid speleogenesis. A model comprised of the following stages can be used to explain the presence of these features. The first being the ascent of hydrogen sulfide gas associated with hydrocarbon seepages from the Cretaceous reservoirs under reducing conditions, followed by oxidation to sulfuric acid, and then several other factors are listed here. Have any of you figured it out yet? I'll quote some more here. The study sets the paleokarst features of the Giza Pyramids Plateau within a hypogene sulfuric acid karst system developed by the action of groundwater containing hydrogen sulfide, sulfuric acid, and carbonic acid. Okay, so first, what is a karst? A karst feature is defined as follows: as a type of landscape where the dissolving of bedrock has created sinkholes, sinking streams, caves, springs, and other characteristic features. Karst is associated with soluble rock types such as limestone, marble, and gypsum. In general, a typical karst landscape forms when much of the water falling on the surface interacts with and enters the subsurface through cracks, fractures, and holes that have been dissolved into the bedrock. After traveling underground, sometimes for long distances, this water is then discharged from springs, many of which are cave entrances. Exactly what we see on the Giza Plateau. Next, and I'll resume quoting here, the Eocene carbonates overlie the Cretaceous rock succession, which in many oil fields of the Western Desert are developed, constituting a potential source rock and good reservoir for economic oil and gas production. And here we have another major piece of evidence substantiating my hypothesis about the presence of hydrocarbon deposits, specifically natural gas methane, below the bedrock in Saqqara, which are the same type of deposits that are extracted all over the Western Desert oil and gas mining fields. This has also been corroborated by the European Space Agency, showing vast concentrations of methane gas deposits surrounding the Nile River. Next, in light of this geological setting, the study discusses the origin of the studied mineral deposits within the host Middle Eocene rock sequence in relevance to hydrocarbon gas seepages from the subsurface accumulations. The associated hydrogen sulfide gas to the petroleum is probably bacterial in origin, oxidized upon reaching groundwater and resulting in highly concentrated sulfuric acid that can result in the formation and precipitation of sulfates. The present work also suggests that the paleokarst features observed in the carbonate rocks of the Giza Pyramids Plateau were formed via the action of sulfuric acid-rich solutions beside the action of carbonic acid-rich solutions. So they are presenting the existence of hydrogen sulfide gas coming from below the Giza Plateau that is associated with sulfuric acid and carbonic acid that created this cave system. Allow me to reiterate this point. There is a vast reservoir and supply of hydrogen sulfide gas directly below the pyramids of the Giza Plateau. All right, now, here is the area that was investigated in the study with some predominant features mentioned previously, the Great Pyramid here, and the entrance to NC2, the Tomb of the Birds, here. Next, this stratigraphic section showing the geological deposits of various materials during the formation of the Giza Plateau bedrock that was the bottom of the ancient Tethys seafloor hundreds of millions of years ago, and some images of the minerals that were evaluated during the research process that included chemical analysis of samples as described here. The X-ray fluorescence technique was used for the analysis of major and trace elements with a very high accuracy. It covers a range of elements from beryllium to uranium using ceramic RH wide range tube. The XRF analysis was conducted for powder samples of nodules and the host rocks using XRF equipment PW2404 with 6 analyzing crystals. Crystals LIF 200 and LIF 220 were used for estimating calcium, iron, potassium, titanium, magnesium, and other trace elements from nickel to uranium, while crystal TIAP was used for determining magnesium and sodium. Crystal GE was used for estimating phosphorus, and crystal PET for determining silicon and aluminum, and PXI for determining sodium and magnesium. And the results of this XRF analysis, which you can see here, correspond directly to the chemical analysis data that I have presented here on the channel, with the iron veins forming as a result of these hydrothermal processes that deposited various metallic ore minerals into the bedrock substrate of the Giza Plateau. But this is where it gets really interesting. Remember this image that I presented back in episode 153 of what I anticipated to be revealed by the synthetic aperture radar team? Take a look at this here. And I'll read the conclusions of the paper first, and then we'll examine in detail this diagram. So, the Mineral Deposits Association described in the present contribution reveals new insights into the speleogenesis of the Giza Pyramids Plateau, the formation of natroalunite, APS minerals, hydrated halloysite, iron and manganese oxides, and replacive gypsum indicates deposition in acidic environments in which sulfuric acid-induced dissolution of the carbonate bedrock and alteration of the associated clays are the predominant processes. Formation of hollows at the contact between carbonates and replacive gypsum, cavities within dolostones, and hollow rhombs with dissolved core and accumulation of ochres, calcareous mudstones, and salt minerals represent the main dissolution features supporting the speleogenetic genesis of the present mineral deposits. The present work reports for the first time the development of hypogene sulfuric acid speleogenesis within the cavernous Middle Eocene beds of the Giza Plateau, and their relevance to ascending hydrogen sulfide gas associated with hydrocarbon seepages from the underlying Cretaceous reservoirs. The suggestion that groundwater containing hydrogen sulfide and sulfuric acid, in addition to carbonic acid, have played a role in the development of paleokarst features of the Pyramids Plateau sets the dissolution features of the plateau within a hypogene sulfuric acid karst system. So to reiterate, the main takeaway from this research paper is that there are subterranean sources of hydrogen sulfide gas deposited in the bedrock of the Giza Plateau that resulted in the development of sulfuric acid and carbonic acid speleogenesis or cave formation. This hydrogen sulfide gas is the primary source of sulfur and is, quote, ascending or naturally rising up from within the bedrock to the surface of the Giza Plateau. And in this diagram, you can see exactly what I predicted in episode 153, a combination of deep vertical shafts all across the Giza Plateau in combination with horizontal cave complex features. These vertical hydrothermal fissures are feeding hydrogen sulfide gas from within the bedrock up to the surface of the Giza Plateau. I cannot stress enough the importance of this discovery and this exact diagram to understanding the function of the Giza Plateau system, as these ancient, possibly hundreds of millions of years old, geological subterranean formations were the inspiration for the construction of the pyramid chemical manufacturing network on the surface of the plateau. And if there was anything to be learned from this synthetic aperture radar team, which at this point is extremely tentative at best, is that they have detected evidence of the existence of this massive underground cave and tunnel network below the Giza Plateau, the source of the hydrogen sulfide gas. So remember, in episode 142, I explained how the Red Pyramid was designed to capture lightning in a bottle, harnessing the same forces of nature that created a chemical reaction in the atmosphere during lightning storms that produced water-soluble nitrate fertilizers, and developing a system that could contain these same forces and reactions to manufacture ammonia in a controlled manner and on an industrial scale. And in episode 143, I presented how the discovery of methane gas, natural resource deposits within the bedrock of Saqqara, provided the impetus for the construction of the step pyramid for the extraction of this valuable, naturally occurring hydrocarbon fuel and syngas source. Well, the exact same mindset of learning from the forces of nature and utilizing the abundant natural resources in Egypt also applies to the construction of the Great Pyramid and the Giza Plateau chemical manufacturing and mining operation. So now, let me introduce this. And I will quote here from this U.S. patent regarding the method for preparing sulfuric acid by using hydrogen sulfide. Provided is a method for preparing sulfuric acid by using hydrogen sulfide. The method comprises the following steps. First, performing a reduction oxidation reaction between a hydrogen sulfide feed gas and oxygen comprised in an oxygen-rich air to prepare sulfur dioxide. Then, performing a catalyzed oxidation reaction with oxygen, wherein the catalyzed oxidation reaction is performed in stages until the conversion of sulfur dioxide is more than 98%. Does any of this sound familiar? It should, as I revealed the exact same process in episode 120 regarding the Great Pyramid ultrasound catalyst, detailing the series of catalytic reactions within the Great Pyramid that produced sulfur dioxide, sulfur trioxide, and the intermediary sulfurous acid, and then the final sulfuric acid product. Furthermore, the patent also states that provided is a heat exchanger. Heat exchanger, you say? Sound familiar? In episode 138, regarding the function of the Great Pyramid void, I also explained the role of this newly discovered chamber located above the contact process chamber and its function as a heat exchanger to remove the excess heat energy from the exothermic reactions occurring in the contact process chamber. And finally, I'll resume quoting here, the method for preparing sulfuric acid from hydrogen sulfide provides high removal efficiency of hydrogen sulfide, simple process flow, and allows for economic efficiency of apparatus and reasonable utilization of energy. So the source of this ascending hydrogen sulfide gas comes directly from the bedrock cave system below the Giza Plateau, and it is drawn up to the surface into the sulfide converters. And I have a special episode on these structures coming up soon, where the hydrogen sulfide gas is reacted with oxygen to produce sulfur dioxide and water. The sulfur dioxide is then pumped into the Great Pyramid and introduced into the reaction system through the gas inlet shaft. We now have the furnace chamber here, and we will add in the two components that are missing from the diagram. The red granite slabs in the acoustic catalyst antechamber and our sulfur dioxide inlet shaft. The grand gallery is first filled with water pumped into the system from the subterranean chamber. The sulfur dioxide gas is then introduced into the furnace, filling the chamber. And then the induced electric fields from telluric currents and lightning activate the inverse piezoelectric properties of the quartz within the red granite components, and the initial conversion of sulfur dioxide and oxygen into sulfur trioxide begins. This is just the tip of the iceberg for what I have in store regarding the function of the Giza Plateau system and the evolution of these pyramids. From simple pumps to complex chemical reactors, and I will be doing a full breakdown, just like what I've presented recently on the Red Pyramid, but exclusively here on the Members Only channel, detailing all of the mechanisms of operation, driving the chemical reaction sequence within the Great Pyramid. But now, you have something that very few people will ever know, that the source of the sulfur gas comes directly from below the Great Pyramid, a natural resource of the Giza Plateau, and the primary reason that this site was selected for the construction of the pyramid complex. All right, everyone, I hope you're enjoying the video, and please remember to subscribe to our 3 other channels: my wife Alexa's channel, Archaeoalchemy, our mutual international travel and culinary adventure channel, Let's Go with Lex and G, and the best channel on YouTube, Egyptian Trash Cats. For all you cat lovers out there, ladies and gentlemen, as always, thank you all so much for the support. Now, back to the video. In the previous episode, Members Only 24, I explained the role of the external reservoir and the function of the subterranean pump chamber system, as shown in the following animation. And I'll run this now so you can see it in operation, bringing us to the next component within the pyramid, the contact process chamber. Let's go. All right, now, some quick measurements and math regarding the contact process chamber filling process. So within the northern pump shaft, we have approximately 120 cubic meters of water. And the contact process chamber itself, the Grand Gallery, is an estimated 620 cubic meters of volume. And given that we are only filling the chamber to the step before the antechamber, let's say it takes 4 activations of the northern pump shaft to fill the contact process chamber to the desired level, as you will see reflected in the next sequence animation. With this image here being where we left off in last month's episode. So the contact process chamber, filled to its maximum level, is shown here. So how is this chamber integrated into the manufacturing sequence? Well, in my opinion, this is one of the most ingenious mechanisms of operation within the Great Pyramid system, as this chamber is designed to draw air into the sulfur furnace through the air inlet shafts. So let's go back to episode 80, Why is the Grand Gallery Slanted?, where I first proposed that the Grand Gallery operates like a syringe, a function which is blatantly obvious when you view the component from above, as shown in this diagram. And by manipulating the volume of water within this syringe, air, which on its own will not be pulled into the air intake shafts, will now start to be sucked into the sulfur furnace chamber, providing the oxygen that is required for the chemical conversion of sulfur dioxide into sulfur trioxide. As I've been saying over and over, the conventional nomenclature attributed to these components tell you exactly what they are for and how they functioned. For example, the well shaft literally being a water supply for the internal chamber system, and the air shafts literally being an air delivery mechanism that fueled the oxidation reactions within the sulfur furnace. So now, let's briefly review the role of the antechamber in this process, which facilitates the unidirectional flow of gases from the sulfur furnace through the acoustic catalyst chamber and into the contact process chamber, through these grooves in the southern wall of the antechamber, a system that was specifically engineered to allow the flow of gases being generated in the sulfur furnace to move through the acoustic antechamber, over the red granite slabs, where the electric field induced ultrasonic vibrations within the quartz filled granite convert the sulfur dioxide into sulfur trioxide before it is sucked further into the contact process chamber, a sequence that is only possible by activating this syringe operation within the Grand Gallery system that I will show you now. So back to our diagram here, and I am absolutely stoked to see this full animated sequence once we reach the end of this series, and I will keep adding to this same diagram to illustrate the whole process. But here, we're missing a few components. First, the Queen's Chamber extraction shaft. The shaft below the Queen's Chamber was written about and documented by all of the early explorers of the Great Pyramid and then covered back over by modern blocks. But it has also been corroborated in modern time by the SAR team during their initial scanning of the Great Pyramid, which revealed the full extent of this extraction shaft network leading out of the Queen's Chamber into a series of intermediary storage and distribution tanks, as recently discussed in episode 138, showing the final product extraction process, and in members only episode 23, I presented evidence not only for the supply of sulfide gas providing the raw materials for this chemical manufacturing process, but also for the sulfur dioxide inlet shaft within the furnace chamber. So now, let's add these two features to the diagram, as both will be relevant at this stage of the reaction sequence, as you can see here. So now, to fully describe the function of the Grand Gallery contact process chamber, I'm going to skip ahead to next month's video regarding the function of the sulfur furnace and acoustic catalyst antechamber, and we now have our system filled with sulfur dioxide gas, and it is being transformed into sulfur trioxide. But this reaction requires a source of air, and like I said before, the air on the outside of the pyramid isn't just going to automatically flow down into these shafts. It has to be sucked in, drawn into the chamber by this water-filled syringe mechanism. Well, the Great Pyramid was brilliantly engineered with this exact feature. So what happens when we start to drain the water from this chamber? It will begin to suck air from the outside of the pyramid through the air shafts into the sulfur furnace chamber, gradually pulling it through the acoustic catalyst antechamber and filling the contact process chamber with our mix of sulfur dioxide and sulfur trioxide until the water has reached the lower step, yet another intentional communication marker within the system indicating the process flow. And our contact process chamber is now filled with the reactant gases. So now we have to bring the water slowly into contact with the sulfur dioxide and sulfur trioxide gas, which is exactly why we use this name, contact process chamber, in the modern day manufacturing sequence, and it worked using the exact same principles for this ancient industrial scale chemistry. So we reactivate our pump shaft here, pulling water into the subterranean components, and we run the system again. Now, this refilling process would have been done very slowly, increasing the water level in a controlled manner within the contact process chamber, gradually bringing the water into further contact with the sulfur dioxide and sulfur trioxide gas. But I have animated here the 4 pumps for brevity, and we'll run that now. 1, 2, 3, and 4. Again, gradually bringing the sulfur dioxide and sulfur trioxide reactant gases into contact with the water as the level is raised within the contact process chamber, a chemical reaction that will be explained further in the next episode. But this step was done intentionally, as by slowly raising the water level within the contact process chamber, this potentially hazardous and violent reaction is completely controlled. So before I run the system without any narration, I'll put in some OG clips from back in 2022 when filming inside the Great Pyramid was far less restricted than it is today. Ah, the good old days. And it definitely is not like this inside the system now. And I will show you exactly how this process works from within these reaction components. I hope you enjoy. All right, ladies and gentlemen, here we are inside the Great Pyramid of Giza in what is conventionally known as the quote-unquote Grand Gallery. But as we know, this chamber is so much more. And we are going to proceed into the antechamber. All right, here we go. Finally, everybody's cleared out here. All right, so I'm gonna get some video on the way back through. But as we have a spare moment, here inside the antechamber, and I will be discussing the function of this component upon my return. And you can see here where the vertical blocks were inserted here that originally sealed this chamber, and then the 4 grooves that allowed the passage of sulfur oxides into the contact process chamber. And again, this here is restoration work, and I pointed out some additional restoration work there at the foot. There was a big eroded part here flowing down into the Grand Gallery, which all this has been patched. Same thing here, this is a patch. And passing through antechamber, here we are. Inside the primary chamber. And just a few things to note in here. So this is the termination of the southern air shaft, which leads all the way to the exterior of the structure. So you can see the configuration of that termination. This is the northern air shaft. Also leading all the way to the outside of the structure. In this area here is where stones have been removed, and this is a concrete block. And there's another hole, pit, that leads down here into a chamber underneath the Grand Gallery, at least a pit that goes down here that's been covered up. So this is modern right here. And this one's been removed, as has this one. This is modern, and this is modern, to cover up that hole. And of course, the container.
Resonance box, you can call it sometime. When we talk about machining, we see here some of the evidence of the overcut plate on the corner.
All right, ladies and gentlemen, we are wrapping up here inside the sulfur furnace. of the Great Pyramid of Giza. And we are going to travel through the manufacturing cycle that leads from this furnace chamber through the antechamber and into the contact process chamber. So sulfur oxides were being produced inside of this chamber. And these air shafts were utilized to bring air into this chamber from the outside of the structure, facilitating the combustion process and the production of those sulfur oxides. So as the combustion proceeds, the sulfur oxides were drawn through this antechamber into the contact process chamber. And this was done by draining the water from the contact process chamber, which drew air through these air shafts into the structure. And now those gases would be drawn through this antechamber. Again, remember that this chamber was sealed with 3 granite slabs, and the only way for gas to flow from this chamber through the antechamber into the contact process chamber is created by these 4 grooves. So the stone blocks that sealed this antechamber prevented the liquid from flowing from the sulfur furnace into the contact process chamber, but these grooves allowed the passage of gases that were being drawn through this antechamber to pass all the way through and into the contact process chamber. And so those large slabs of granite were housed in here. All right, ladies and gentlemen, we are back. And I'm going to take you down through the contact process chamber. So inside of this chamber, the sulfur oxides that were being produced inside of the furnace chamber were being dissolved into water, producing the solution of sulfurous acid, which gradually became oxidized into sulfuric acid. Ooh, there you go. And you can see that the entire inside of this chamber appears as if it's been heated to a very, very high temperature. That was the first impression that I got my first time in here in 2017, was that this looked like the inside of an oven that had been baked. But we know that the reaction between sulfuric, or rather the dissolution of sulfurous acids into water, creates an enormous amount of heat. It's an exothermic reaction. So that would certainly explain the appearance of excessive heat inside of these chambers. And I'm going to try to avoid everyone else as they pass through here. And just look at all that oxidation in the upper part of the contact process chamber. And we are moving down toward what is conventionally known as the quote-unquote well shaft, but that's actually connected to the subterranean pump mechanism which was pushing water into these chambers. So your solution is being produced inside of this chamber, which then flowed through this channel down towards your extraction chamber. And we have here the entrance or opening to that extraction chamber system. Here. And this is the opening, excuse me, to the well shaft that connects down into the subterranean chamber. So as we came into the structure, we saw the northern shaft, which leads down into the subterranean chamber. That subterranean chamber is connected into the interior system through this well shaft. And the subterranean pump was pumping water up through this well shaft, which filled this entire system for the production of that acidic solution here inside the contact process chamber. And just a couple things to note: that unusual red color staining on the lower portion of the wall, which looks like it's been chiseled off in places. What is that material that is coating the walls in here? That's right, I use the word coating very intentionally, because there certainly was a chemical sealer involved in protecting the walls of these chambers against the vitriolic effects of these acidic solutions. All right, now, without further ado, the fully animated sequence thus far, now integrating the function of the contact process chamber. Let's go. All right, everyone, as I just mentioned, if you want to help support the channel and get access to some exclusive research content, check out the Land of Chem members-only channel now with a new tier called The Alchemists, featuring a 3-part episode revealing the function of the Teotihuacan Pyramid Complex. Also, a completely unscripted, unedited Ask Me Anything video every single month, now on Part 5. And ladies and gentlemen, I can finally announce a brand new series entitled The Land of Chem in the Lab that will feature a variety of experiments designed to test the hypotheses presented here on the Land of Chem channel. Links to everything in the video description below. Thank you all so much for the support. Now, back to the video.
And to begin, here is a diagram showing the strength of the Earth's magnetic field, which ranges from 25,000 to 65,000 units in nanotesla, a unit applied to describing magnetic field strength, with the strongest concentration surrounding the north and south poles. And as you can see here in Egypt, we lie on a belt in the range of approximately 45,000. And the structures we have been discussing from England and Ireland are in the 50,000 range. So after witnessing some magnetic field anomalies surrounding the stone and earth structures of England and Ireland, I decided to investigate these fields surrounding the Egyptian pyramids. So I downloaded a multi-physics-based application on my phone that will allow me to test different parameters, which includes a magnetometer to detect and measure magnetic field. So this will be an ongoing series of collecting this type of data from around and inside the Egyptian pyramids. So first, I measured the magnetic field where I currently live, which is an area about 40 minutes away from the pyramid sites. And you can see here that it showed 32 or 32,000 when converted to the same nanotesla unit that was shown on the diagram. So it was actually quite a bit lower than the expected 45 that should be present in this area. And this measurement established a baseline of comparison for the field strength around different areas of the pyramid sites.
All right, everyone, we are back. And after 3 weeks of expeditions across the ancient megalithic landscape of England and Ireland, Time to return to the desert. And after getting absolutely drenched for 3 weeks in a row, it looks like we brought it with us. That's right. Something you don't see every day out here. And the ghostly shadow of the Red Pyramid to the north there in the distance. So on today's expedition, where is she? There we go. Got Lex.
Everybody.
From Ancient Odysseys with me, as always these days. Today, we came out here to investigate. Well, I have several things on the agenda for today that I want to take a look at. We'll do our best to determine if there's any magnetic anomalies around some of the stones here at the Bent Pyramid. I've been quite inspired by my research into the ancient stone circles and structures of England and Ireland. And as I mentioned in episode 104, everything that applies to those stone circle systems also applies here at the pyramids of Egypt. So we're going to take a walk around the Bent Pyramid, go over to the Eastern Temple of both the main... Man, that looks crazy when it's wet. All right, so we're gonna walk around to the eastern side and we will take a look at the temple. All right, the next reading that you can see here is from the eastern side of the Bent Pyramid, pressed right up against the casing stones, and it showed 40, a 25% increase in the magnetic field strength compared to our baseline away from the structures. I then tested the magnetic field strength inside the Hotep adjacent to the pyramid, and you can see here another increase up to 45. A 13% increase in the magnetic field strength only a few steps away inside of this quote-unquote Hotep, and a 40% increase away from the baseline reading. And here's a clip so you can see this area of the structure for yourself. All right, we just finished doing some preliminary testing using a magnetometer to evaluate the magnetic field surrounding the Hotep here as compared to the ambient field in the desert, and then up against the casing stones of the pyramid. And to eliminate any interference caused by our electronic devices, I will put in some screenshots of the magnetometer on my phone, which is showing about a 10% fluctuation in magnetic field strength from inside of this Hotep compared to the base of the pyramid and the ambient magnetic field in the desert. And two features that I want to highlight here. It's actually one two-part dual feature, part of a single system with two components, which are the two pillars here, which originally would have risen much taller than this. And these two pillars are absolutely not ornamental or decorative in any way. As you can see, there's no hieroglyphs inscribed upon them, and they are a part of this functional system. And I figured I would give you the absolutely spectacular shot that we have right here. Such an amazing feeling to be back home, back here in the desert. I know, yeah, it's beautiful with all the grass and the greenery and the rolling hills and the views. But this is where it's at for me. And we will be investigating the system here on the eastern side of the Bent Pyramid.
We then walked over to the satellite pyramid, where I tested the area in between the remains of the two stone pillars on its eastern side that you can see here.
All right. And our secondary location for investigation today is here on the eastern side of the Bent Pyramid's satellite pyramid. And there were also two pillars located here on the side of this structure. The extremely deteriorated and eroded remains of which you can see here. So these two fragments of stone here, embedded into the bedrock, used to be two pillars that once stood on the eastern side of this pyramid, and they served a similar function to that of what we just saw on the eastern side of the main structure.
And the magnetometer showed a magnetic field strength in the middle of the pillars, reading 41.7. And then directly above the pillars, an increase of 2 units up to 43.7. And I took all of these readings with the other electronic equipment turned off and kept far away to eliminate any interference. So to summarize, there was a 40% increase in the magnetic field strength from our baseline reading of 32 that increased up to 45 inside the Bent Pyramid's Hotep. And there were fluctuations of the magnetic field above and between the pillars. However, all of these numbers did fall within the normal ranges for the Earth's general magnetic field strength. And yes, I was investigating this area of the structure specifically and intentionally, as it will be coming up soon in a future episode, and I will continue to accumulate data at different sites, including on the Giza Plateau, and will report back with any interesting findings. All right, next up, on to an absolutely major breakthrough in Great Pyramid research. As you can see here, quote, "Study reveals the Great Pyramid of Giza can focus electromagnetic energy." And I will walk you through the results of these experiments and explain how this discovery is directly related to my theory on the function of the Great Pyramid, and it works exactly as I had anticipated. Now, the following comes from the 2018 paper entitled Electromagnetic Properties of the Great Pyramid. First, multipole resonances
and energy concentration, as published in the Journal of Applied Physics. And I will put links in the video description below so you can go read it for yourself. And here, quoted from the paper's abstract, resonant response of the Great Pyramid interacting with external electromagnetic waves of radio frequency range. A wavelength range is from 200 to 600 meters is theoretically investigated. Electromagnetic field distributions inside the pyramid at the resonant conditions are demonstrated and discussed for 2 cases: when the pyramid is located in a homogeneous space or on a substrate. It is revealed that the pyramid's chambers can collect and concentrate electromagnetic energy for both surrounding conditions. In the case of the pyramid on the substrate, at the shorter wavelengths, the electromagnetic energy accumulates in the chambers, providing local spectral maxima for electric and magnetic fields. It is shown that basically the pyramid scatters the electromagnetic waves and focuses them into the substrate region. So you can see here that radio waves lie on the lowest energy end of the electromagnetic energy spectrum, and they have very long wavelengths as compared to higher energy electromagnetic energy waves with much shorter wavelengths. And you can see here that AM radio waves have a wavelength of 100 meters. And this team is using even lower energy, longer wavelengths of 200 to 600 meters. Extremely low energy and long wavelengths in comparison to the rest of the electromagnetic energy spectrum. And this will be relevant as we reach the conclusions of the paper and applications of the properties demonstrated in relation to my theory on the function of the Great Pyramid, which is for the production of sulfuric acid via a sonochemical reaction that harnesses lightning to create ultrasound within the red granite of the furnace as amplified inside the acoustic antechamber. Now, on to the parameters of the experiment, first examining the pyramid shape in a homogeneous environment. And I will quote here, we first study the scattering of an external radio frequency electromagnetic wave by the pyramid located in a homogeneous environment. It is known that the pyramid blocks are made of limestone. From the literature, one can observe that the limestone permittivity value slightly varies in the range of 4 to 6 depending on porosity, temperature, humidity, etc. So permittivity is defined here as a constant of proportionality that relates the electric field in a material to the electric displacement in that material. And this is directly related to everything that I have been presenting regarding the dielectric properties of limestone and various other materials, and their capacitance for the storage of electric fields as expressed by their dielectric constant. As you can see here at the bottom, this definition of permittivity coming from an excerpt discussing dielectric, electric fields, and capacitance from Encyclopedia Britannica. So, as I have proposed, the reason the electric field concentration phenomena that are revealed in this paper are possible is due to the dielectric properties of the limestone. One thing to keep in mind is that they do not take into account the use of red granite in the construction of the Great Pyramid. But red granite has a similar dielectric constant to that of limestone. So for the purposes of this experiment, it is not particularly relevant. However, it definitely is relevant when applied to my hypothesis about the function of these two chambers. So for the first series of experiments, they applied the radio wave electromagnetic field from the top, following the vector indicated here at K, with the pyramid shape in a homogeneous environment. And this is what they found for several different wavelengths. And you can see here that they tested 333 meters, 285 meters, 230 meter, and 200 meter wavelengths. And they are showing both the electric field concentration at the top and the magnetic field concentration at the bottom. And for the purposes of today's episode and my research, we are going to analyze in depth specifically the electric field concentration. And you can see here the shorter wavelengths of 230 and 200 meters, there was an intense concentration of the electric field around the King's chamber, as indicated here with this black rectangle. And here's a close-up image where you can see the black rectangle here and here, indicating the relative position of the King's chamber within the structure. And the red areas indicate the highest strength electric field at 230 meters here on the left. And at 200 meter wavelength, the red completely fills not only the King's chamber, but also the surrounding areas, which would also include the antechamber. Pretty interesting stuff, but this is just the beginning. Next, the electromagnetic field was applied from the bottom, according to vector K, which you can see here. Again, with the pyramid in a homogeneous environment with these results. Not much happening in terms of concentration of electric fields inside of the chambers, but some interesting effects shown here at 230 meter wavelength in D, and also some electric field concentration at 330 meter wavelength, as shown here on the left in A. And a close-up of image A, and you can see some red, intense electric field concentration here inside of the black rectangle, indicating the King's chamber. But now, here is where things get even more fascinating. And I will quote here, "Next, we study the more realistic case when the pyramid is located on the limestone plateau, i.e. substrate, as depicted in figure 5A. So basically, they added the limestone base of the Giza Plateau itself to the experiment. And they focused just on the electromagnetic energy coming into the top of the structure, again indicated here by vector K, and you can now see the limestone substrate of the Giza Plateau added to the experiment parameters. And this vector K is directly relevant to my theory about the Great Pyramid being struck by lightning, and the results were exactly what I had expected. So here, you can see that in the shorter wavelength, higher energy electromagnetic fields, there was significant concentration of the electric field into the area surrounding the King's chamber, and also a distribution of that electric field into the bedrock of the Giza Plateau. And the application of this phenomenon as related to the production of acidic solutions and the leach mining of metallic ore deposits will all be coming up soon. And it works exactly as I had anticipated. Now, let's take a look at some close-ups, remembering that these examples are looking at the electric field concentration and distribution when the electromagnetic energy is directed into the structure from above, including the limestone bedrock substrate. And here you can see that the two lower wavelengths with higher energy of 250 meters and 220 meters, showing concentration of the electric field in the area encompassing the King's and antechambers, and the intense distribution of the electric field into the bedrock of the Giza Plateau. This is absolutely fascinating, but there was an additional finding that I did not expect, as you can see here. And I will quote, "Another important observation we did is the concentration of electromagnetic fields inside the pyramid, and especially inside its chambers at the wavelength of 200 meters. At the shorter wavelengths, the field intensities increase in comparison to the longer wavelengths. Interestingly to note that the accumulation of the electromagnetic energy in the chamber under the pyramid is realized in the electromagnetic focusing region." And you can see down here at the bottom left that the subterranean chamber also experiences some concentration of the electric field at the shortest wavelength used in the experiment of 200 meters. And a close-up of that image here, where they have included the relative position of all three chambers: the King's chamber, the Queen's chamber, and the subterranean chamber. So in conclusion, I will quote, "The multipole analysis of the electromagnetic wave scattering by the Great Pyramid has been performed in the radio frequency range and revealed important physical properties concerning the accumulation and focusing of electromagnetic energy. It has been shown that the pyramids can resonantly scatter electromagnetic waves and support resonant excitation of electromagnetic multipoles, which resulted from strongly electromagnetic fields in the pyramid volume. More importantly, for the pyramid located on the substrate, we have found that it basically scatters electromagnetic waves into the substrate, i.e. the bedrock of the Giza Plateau, where the focusing effect is observed. It was established that the pyramid's chambers can concentrate electromagnetic energy at the resonant conditions. In the conclusion, note that the excitation of the pyramid with shorter incident wavelengths could result in the excitation of higher order resonances with strong field concentration effects. So now, how does this apply to my theory on the function of the Great Pyramid? Well, first, they are using extremely low energy electromagnetic waves, which demonstrate the potential capabilities of the pyramid geometry and position of the chambers to concentrate electric fields within the structure. However, they state directly that these effects could be intensified by decreasing the wavelength and increasing the energy introduced into the system, which requires further investigation. So remember from the beginning of the video that they were using low energy, low frequency radio waves to produce these effects, but the findings suggest that using higher energy, higher frequency waves could increase the concentration of these electric fields within the chambers. Also, when red granite is introduced into the equation, we will not only have concentration of the electric field in the King's chamber and the acoustic catalyst antechamber, but also the electric field will induce the inverse piezoelectric effect within the quartz inside the red granite, which will produce ultrasound, which is then amplified within the acoustic catalyst antechamber, just as I've explained previously in episode 100. Next, what happens when we replace the electromagnetic energy completely, removing these low energy, low frequency radio waves and replacing it with an immensely powerful, instantaneous electrostatic lightning discharge directly into the structure. This, ladies and gentlemen, is where the Great Pyramid will come alive. In last week's episode discussing this paper, Electromagnetic Properties of the Great Pyramid, First Multipole Resonances and Energy Concentration, I intentionally left out one of the results that were discovered in this series of experiments, which you can see here, as it is so important that it deserves its own episode and provides conclusive evidence for my hypothesis as presented in episode 106, that the Great Pyramid never had a capstone, allowing the accumulation of an electric field at the top of the structure, providing a target for lightning strikes. So now let me explain exactly what you are seeing in this image. So recall from episode 106 that telluric currents, natural electric currents flowing in the Earth's crust and mantle, known as terra levis or shallow earth currents, quote, have a controlling impact on the strike locations of cloud to ground lightning. And remember this statement, as I will be coming back to it at the end of the video, that these natural electric currents have a controlling impact on the strike locations of cloud to ground lightning. Basically, that these electric fields accumulate charges on the surface of the Earth that attract lightning strikes of opposite polarity from cumulonimbus clouds. And I hypothesized that the limestone dielectric material composing the body of the Great Pyramid would create electric polarization within the stone structure, creating a positive electric field distribution near the apex of the structure. So now I'm going to show you how this study provides conclusive experimental research-based evidence that proves not only my hypothesis on this mechanism of operation, but also my proposition that the Great Pyramid never had a capstone. So recall this experiment from the study, where the electromagnetic energy in the form of radio waves were directed into the body of the pyramid, as shown here, in the direction of vector k, exactly as would occur with the naturally occurring telluric currents flowing up to the surface through the Giza Plateau into the Great Pyramid. And you can see here that at the lowest frequency wavelength of 230 meters, an absolutely spectacular phenomenon occurs where a tremendous electric field accumulates near the top of the structure. But the area where this hypothetical quote-unquote capstone would be is completely unaffected, leaving a flat, exposed surface that is teeming with an electric field at the top of the structure, as shown here on the top right in diagram D. And this is what it looks like. Clear as day, you can see exactly what I hypothesized and explained in episode 106 being proven by experimental research, that the dielectric limestone material of the Great Pyramid and its geometry create the accumulation of an electric field at the top of the structure. So just look at the diagram here, where the red indicates the most intense concentration of the electric field. And the area where this quote-unquote capstone would be is almost completely unaffected, which is why the Great Pyramid of Giza was intentionally designed to be flat at the top, to allow the accumulation of these electric fields, which are known, again, to have a controlling impact on the location of cloud-to-ground lightning strikes,
as empirically proven in the paper that I showed at the beginning of episode. And these electric fields build up on the top of the structure, providing a target for cloud to ground lightning strikes directly into the top of the pyramid, exactly as I presented in episode 106. But this is just the beginning of the evidence for my theories that were demonstrated in the experiments from this paper. And in part 3 of this series, Electric Fields Inside the Great Pyramid, I will show exactly how these electric fields directly impact the chemical reaction process within the structure for the production of a dilute solution of sulfuric acid that was utilized for the acidic leach mining of metallic ore deposits on the Giza Plateau. But also recall that the production of sulfuric acid is an extremely exothermic reaction, the heat energy from which has a direct application in the generation of more cumulonimbus clouds. This is a continuous cloud and lightning creating circuit, just as described with the Chalk Hills of Wiltshire and Silbury Hill, but with a more complex mechanism of operation, indicating the evolution from the chalk, mound, and hill structures of England and Ireland into the chemical reaction chambers of the Egyptian pyramids.
All right, everyone, I hope you're enjoying the video, and please remember to subscribe to the Land of Chem here on YouTube if you're interested in the physics and chemistry technology of a lost civilization and the function of the Egyptian pyramids and other ancient structures from across the world. Thank you all so much for the support. Now, back to the video.
And today we will examine the function of the red granite components inside of the Great Pyramid, specifically the King's Chamber, the antechamber, and the plug blocks located here, which were originally housed at the top of the shaft here, as you will see in just a moment. And if you're new to the channel, I highly recommend the playlist, all episodes starting from the beginning, because you have a lot to get caught up on. And I'll be referring to information in today's episode that was already explained in episode 45, 60, 74, 79, 80, 82, 92, 100, 102, 106, 108, 109, and 117. And I have already created a playlist with all of these episodes focusing on the function of the Great Pyramid so you can get brought up to speed, as I am not going to re-explain material that has already been presented. So, as the reaction sequence began, the King's Chamber, here, was filled with sulfur dioxide gas, and the contact process chamber was filled with water. This priming mechanism was precisely timed to occur in conjunction with the strategically timed lightning strikes that were being produced by the cumulonimbus cloud generation system of the Giza Plateau, which will be coming up soon. And when lightning struck the top of the Great Pyramid, the electric field permeated the limestone body of the structure, a dielectric material with the capacity for storing these fields. And the electric field energy was concentrated primarily within the areas surrounding the sulfur furnace chamber and the acoustic catalyst antechamber, as you can see here from episode 109, presenting the study showing the ability of the Great Pyramid to focus electric fields inside of these chambers. But remember, these reaction chambers were not made from limestone. They are constructed from red granite, which is also a dielectric material with the capacity for storing electric fields. But it has an even higher dielectric constant and thus capacitance than limestone, which has a dielectric constant of 6. But red granite has a dielectric constant of 9. So it has an even higher threshold for the storage of electric fields. And we know that red granite contains a very specific type of material, crystalline quartz. And as presented first in episode 79, I will quote here, "When quartz crystal is subjected to an electric field, a strain proportional to the electric field will be generated. This phenomenon is called an inverse piezoelectric effect. And this inverse piezoelectric effect produces vibrations within the quartz crystal that generate ultrasound waves.
the distribution of electric fields from lightning through the limestone core into the red granite dielectric material of the furnace and catalyst antechamber within the Great Pyramid is how the acoustic properties of this structure were activated via the inverse piezoelectric property of the quartz crystal. And I presented in episode 100 how those ultrasound waves can be used as effective catalysts to create chemical reactions, a field now known as sonochemistry. And I will quote here from this article entitled Sonochemistry, Science and Engineering. Sonochemistry is the use of ultrasound to enhance or alter chemical reactions. Sonochemistry, in the true sense of the term, occurs when ultrasound induces true chemical effects on the reaction system, such as forming free radicals, which accelerate the reaction. However, ultrasound may have other mechanical effects on the reaction, such as increasing the surface area between the reactants, accelerating dissolution, a factor that will be relevant today, and or renewing the surface of a solid reactant or catalyst. So these ultrasound waves are an extremely powerful tool for producing chemical reactions, specifically via a phenomenon known as acoustic cavitation. As stated here in this article entitled Sonochemistry, Uses of Ultrasound in Chemistry and Related Disciplines. The term sonochemistry is used to describe a subject that uses sound energy to affect chemical processes. This terminology is in keeping with that of the longer established methods that use light, photochemistry, and electricity, electrochemistry, to achieve chemical activation. It might be argued that a more accurate description of the subject would be cavitation chemistry, since the majority of the applications rely on the energies generated by acoustic cavitation. However, sonochemistry is the established term, and certainly over the last few years, giant strides have been made in the subject. Gone are the days when sonochemistry was considered to be a quote-unquote black art, and simply a method of initiating intransigent reactions, particularly those who depend on the activation of metallic or solid reagents. Sonochemistry has moved a long way since its beginnings in the 1940s and 50s, through its renaissance in the 1970s, to where it now stands, a major new technology available to scientists from a wide range of disciplines. This mechanism of sound-catalyzed chemistry, the so-called black art, takes us full circle to the first slide that I ever made for a Land of Chem video, presented in episode 1, explaining the play on words that is the title of my book, The Land of CHEM, as in the Land of Chemistry. As you can see here, the word chemistry derives from the word alchemy, which is derived from the ancient Egyptian name of Egypt, Khem, chem, meaning blackness. Therefore, alchemy can be seen as the Egyptian art, or the quote-unquote black art. So this black art of ancient alchemy, utilizing sound as an acoustic catalyst for sonochemical reactions, was being performed as these electric fields were concentrated inside of the sulfur furnace and antechambers of the Great Pyramid to facilitate a reaction between the sulfur dioxide being produced in the furnace chamber and the oxygen from the atmosphere being drawn into the chamber through the air shafts. And as those gases were pulled through the red granite acoustic catalyst antechamber through the 4 grooves in the southern wall that you can see here, as explained in episode 100, they were concentrated in the area above the 3 red granite slabs and exposed to ultrasound energy. And these ultrasonic waves were reverberating through the chamber, being produced by this electric field-induced inverse piezoelectric effect, beginning to catalyze the reaction between sulfur dioxide and oxygen from the air to produce sulfur trioxide, as you can see in the chemical equation here. but there is a brilliant mechanism of operation embodied within the operation of this chamber, whereas the sonochemical reaction would not convert all of the sulfur dioxide into sulfur trioxide, as the final reaction would occur in solution via acoustic cavitation within the contact process chamber. So we have here the sulfur dioxide and oxygen being pulled through the antechamber. As explained in episode 80, why is the grand gallery slanted? Flowing through the antechamber here, being partially catalyzed by ultrasound waves to produce a mixture of sulfur dioxide and sulfur trioxide, which are then pulled through the antechamber into the contact process chamber. The water level is then raised inside of the chamber, bringing the water into contact with the two reactant gases, which will produce a series of chemical reactions. First, the sulfur dioxide will dissolve into the water more efficiently than the sulfur trioxide, producing an aqueous solution of sulfurous acid. That sulfurous acid is then immediately further oxidized by the air in the chamber, as explained here. Sulfurous acid is a weak acid. It changes to sulfuric acid on exposure to the atmosphere via this chemical reaction here, showing the sulfurous acid reacting with oxygen to produce sulfuric acid. So then within the water-filled contact process chamber, the oxidation of sulfurous acid is catalyzed by acoustic cavitation from the ultrasound waves emanating from both the antechamber up here and the red granite plug blocks down here in their original housing at the top of the shaft. Following this equation here, again, sulfurous acid being oxidized by oxygen into sulfuric acid to produce the solution of sulfuric acid within the contact process chamber. And according to the conventional archaeology, this was the position of the red granite blocks in their original housing at the base of the Grand Gallery before they were pushed further down the shaft. And these red granite blocks would have also been affected by the electric fields being introduced into the pyramid, activating the same inverse piezoelectric ultrasound production as within the antechamber, sending acoustic waves up through the solution to induce this acoustic cavitation oxidation reaction. And I had a conversation with a mechanical engineer during my last tour when I explained my hypothesis of this mechanism, and we agreed that these red granite plug blocks may have also functioned as a multi-phase emergency pressure release mechanism, so that if the pressure within the contact process chamber ever got too high, it would force these plug blocks to break loose of their housing, pushing them further down the shaft, thus relieving the pressure inside of the system and preventing catastrophic destruction of the entire pyramid structure. So now, back to the chemistry. Experiments have been done that prove that this reaction, the acoustic cavitation oxidation of sulfurous acid into sulfuric acid, is absolutely possible. As you can see here, catalytic oxidation of sulfur dioxide by oxygen in an aqueous solution of sulfuric acid in the presence of bivalent manganese ions under ultrasound irradiation. As stated here in the abstract, ultrasound irradiation is shown to cause oxidation of sulfur dioxide by oxygen in an aqueous solution of sulfuric acid containing manganese ions as a catalyst with an energetic yield typical for chain reactions. And I'll be getting to these metal ions in an upcoming episode regarding the missing components from within the Grand Gallery. But this multi-stage intermediary chemical reaction sequence of first dissolving sulfur dioxide to create sulfurous acid, then further oxidizing it within the chamber to produce sulfuric acid, and finally dissolving the remaining sulfur trioxide into a solution of sulfuric acid would happen almost instantaneously within the chamber, as the sulfur dioxide more easily reacts with water and would immediately dissolve into solution and oxidize into sulfuric acid. So essentially, the sulfur trioxides generated in the antechamber are being dissolved into a solution of sulfuric acid, a much more manageable reaction than dissolving them into water. And this is exactly what we do today in the modern contact process, where the sulfur dioxide generated in the furnace chamber here is reacted with oxygen within a catalyst chamber, and the sulfur trioxides are then dissolved into sulfuric acid to produce oleum, and then further diluted to render the final solution of sulfuric acid. And I showed in episode 77 a comparison between modern and ancient alchemy. There is nothing new under the sun, one of my favorite episodes ever produced here on this channel. How the chambers of our modern contact process emulate the ancient reaction chambers of the Great Pyramid, with the King's Chamber featuring both of the air shafts, otherwise known as the sulfur furnace here, the antechamber or acoustic catalyst chamber here, the Grand Gallery or the contact process chamber here, and the Queen's Chamber or dilution and extraction chamber here. And don't forget, as shown in episode 82, the reaction chambers of the Great Pyramid were coated with a chemically resistant coating compound to prevent any corrosion inside of the system. As you can see here, from the Queen's Chamber in 1978, Dr. Patrick Flanagan asked the Arizona Bureau of Geology and Mineral Technology to analyze a sample of the salt found coating the Queen's Chamber. They found it to be a mixture of calcium carbonate, limestone, sodium chloride, salt, and calcium sulfate, gypsum, otherwise known as plaster of Paris. And here, in an excerpt from Zahi Hawass on the restoration of the Great Pyramid, the walls of the Grand Gallery were found to be covered with up to 2 centimeters of salt. The walls of the Grand Gallery were cleaned of this salt residue. And in this image, you can see a carving of a calcium sulfate anhydrite kiln carved into a piece of the same material. And this is exactly what the coating looks like inside of the Great Pyramid. And this is why it works, as stated here. When reacting a block of solid calcium carbonate, limestone, with dilute sulfuric acid, solid calcium sulfate is produced, which is deposited on the surface of the calcium carbonate block. So here we have a solid deposit of calcium sulfate being formed on the surface of the limestone. The calcium sulfate is insoluble in dilute sulfuric acid, and so you end up with calcium carbonate limestone coated in a layer of calcium sulfate, which is exactly what was discovered inside of both the Queen's Chamber and the Grand Gallery. And this calcium sulfate stops the acid from getting at the carbonate and so stops the reaction. So during the first activation of the Great Pyramid, the inaugural production run created an insoluble, chemically resistant coating compound of calcium sulfate salt that protected the reaction chambers permanently from any further corrosion damage. So now I'll put in some clips so you can see the acoustic catalyst antechamber and the contact process chamber for yourself, both of which still show evidence of this oxidation reaction to create the final sulfuric acid product.
You can see inside of this chamber, as with in almost all areas of the Great Pyramid,
there is pretty significant oxidation here. You see there? And you see that all throughout the Grand Gallery. So again, we're taking the same passage that those gases would have flown through, and this is a passage that was excavated around the antechamber. And you can see here, this is where those gases would have dropped down. So this is also in the antechamber here. This is looking back to where we just were. You can see those grooves on the other side of this stone partition. The gases would have flown down through here, passing through into the contact process chamber. And as I mentioned before, this whole area here is patchwork. This was originally all eroded out of the structure and has been patched with modern concrete. As I showed before, the patch on the lower portion of the antechamber. So now we move here into the contact process chamber, and you can see all of that oxidation on the upper point of the tiered vault system. And bear with me, and I will take you in a journey down through this chamber as we proceed towards the extraction and collection chamber and the subterranean pump system in just one moment. And we're back. Here, looking down into the depths of the contact process chamber. And you will notice that the entire inside of this chamber looks like it's been heated to an extremely high temperature. An indication of the exothermic reaction that was occurring inside of this chamber. The dissolution of sulfur oxides in water producing sulfurous and sulfuric acid is an extremely exothermic reaction. And in one moment, we're going to be crossing the threshold here into the antechamber, leading into the furnace chamber. So the lights are back on. We are here around 4 o'clock in the afternoon. Much less people on the Giza Plateau. Ascending the staircase into the contact process chamber of the Great Pyramid. And you can see here that they do have electricity wired into the light system, which is now working today. All right.
Devam ediyoruz yukarıya. Haydi bakalım.
Go. And let me get out the light here. Ooh. Here we go.
And if you look up there, it certainly looks like there's some concrete or plaster in through here. See, there's remnants of mortar here. And look here. This layer of material, this red material here. Coating material. Huge patch right here. Look at that. And this is leading into the entrance of the extraction chamber system. Okay. And I'm glad they have the lights on. So that's most likely some modern concrete here. This is patchwork here. Modern patchwork. Now looking back down into the descending passage. This patch here looks to be exposed limestone, and then you can see the elevated area with the coating. Alright, so now we're going to ascend into the contact process chamber. And look at how red it is. I hope you guys can see that on the camera. How red the interior of this chamber is. Look at that red color and all in through here. Look at the color of this part here. It's red, all in through here. Alright, ready?
I'm ready. Yeah, the big.
Water. Okay, go ahead. And let me tell you, it is awesome inside of here today. Almost no people. Nice and cool. Look at all those chisel marks going along this part here. It almost looks like there was something installed on that, on this level here. You shine the light right here with that. So this part here, it almost looks like there was a bar or something installed all the way down here. And look at those chisel marks. As you can see here, as we move up this direction, this is pristine. This part of the channel here, to the left of the chisel marks, this area here, we'll get a little closer to this. Move up just a little bit. So there may have been something fitted into that area that's been chiseled out of there. You can see the chisels at the top. In this area, so this is the bottom of the tier here. But you can see there's a channel right above it here. see if it's on the other side. Yep. You see that channel running down that same tier. And then the chisel marks start there. And the big chiseled out patch there. Running all the entire length of the chamber. So now we're going to look at these. And this material here is patched. This pink stuff. So this has all been patched up. Yeah. Thank you. And over here on the left, look at, and you can see the patched area here. This is all patchwork here. Certainly looks like some iron oxide right there. Okay. Short round. All right. Looks like some iron oxide. These housings. And some of them have been filled in, patched over. You see the material that fills out the hole here. So that's all been patched up. And you can see here, running down along the bottom, this is a conduit for the electricity. This is for a wire. There's a wire running in here, connected into the electrical system. That's powering these, which are, thankfully, again, all this is patched here. All patched up. Same over on this side. So this is all a big patch here. This appears to be original limestone. And then this here is the ancient mortar, the coating compound that covered up the limestone. And you can see how, if you were here in person, you can see how stained that was. So this is exposed limestone here. This is a piece of the coating. See that? Pretty crazy. All right. Alright, so here's a section. See this stained section here? This is all still covered in coating. This part here with the black drip stains on it. And exposed limestone. Coated, exposed. And here we go, through the antechamber. And I'll be doing a very special episode on the antechamber of the Great Pyramid for episode 100 here on the land of Khem. And you can already hear that within this chamber the acoustic properties are the most magnified in the entire structure. So we have these 4 grooves. This is a patch here. This is restoration work. There were originally some beams of stone here. And you can see the remains of one here that have been knocked out of place. And there were 3 large slabs of granite, one here that went all the way to the floor. In these housings, okay, so you imagine this piece comes out several inches, and the piece of granite was locked into place in between these two bilateral housings. So a huge piece of granite here, piece of granite here, and then a piece of granite here. But this piece did not go all the way to the floor. It stopped right here. And as I explained before, dropping the water level in the contact process chamber would draw the gases from the sulfur furnace chamber up through these grooves passing over and then falling down into the contact process, being drawn into the contact process chamber. Man, that's an awesome shot. All right, so now into this small intermediary chamber. Listen to that. This area of the Great Pyramid has by far the highest amount of acoustic amplification. And I'll be right back. All right, so now we'll begin our descent back down through the contact process chamber. And on the ascent, and I showed you some of the most anomalous details that I've ever recognized here inside the structure. The intense staining on the coated original portions of the walls. The housings that appear to still have traces of metal oxides. The patching, the coating compounds, the oxidation in the ceiling, which you can see above us. Look at this piece right here. Look at that black staining there on that tier. I mean, this entire structure looks like it's been baked on the inside. Extremely high temperature exothermic reaction, dissolving sulfur trioxide gas into water produces an extreme amount of heat energy. Hence the volume of this massive chamber. As explained in the episode Why is the Grand Gallery Slanted, it prevented the whole thing from boiling over out of control. The more water you have, the smaller amount of sulfur trioxide, the more you can control the reaction. If you have a significant amount of sulfur trioxide and a tiny amount of water, the solution is going to boil over out of control. So these two things were mixed gradually with an excessive volume of water, producing a very dilute solution of sulfuric acid that could then be concentrated if needed, depending on the application. Quite a different experience exploring the Great Pyramid with the lights back on. Of course, as always, completely soaked because it is hot AF inside that King's Chamber, but much more tolerable. Very few people in here today and quite an amazing experience. So now we're going to continue with the exploration of the Giza Plateau.
Now to begin, in members only episode 25, I completed the function of the subterranean pump chamber and the first mechanisms of operation within the contact process chamber. And I'll run the animation now so we can get caught up to today's episode. Let's go. All right, now, what you are about to see is the most comprehensive examination of the research that I have presented thus far regarding the function of the sulfur furnace, including the materials, mechanisms of operation, and chemical reactions, beginning back in episode 79, Inverse Piezoelectric Effect and Ultrasound, where I first presented the concept that the red granite within the so-called king's and antechambers was a material specifically selected for its quartz content, and by inducing an electric field within the dielectric stone material through applied voltage, the inverse piezoelectric effect would be activated, producing ultrasound. And in episode 100, the acoustic catalyst chamber of the Great Pyramid, I explained how this chemical reactor component, the sulfur furnace, and the antechamber were brilliantly engineered to implement these electric field activated ultrasonic vibrations to achieve sonochemical reactions. Sonochemistry is a branch of chemical research dealing with the chemical effects and applications of ultrasound waves. This groundbreaking area of scientific chemistry has a variety of applications, including the production of metal nanoparticles, as demonstrated regarding the function of the Osiris shaft system in Members Only Episode 9. So, to further define the chemical process within the sulfur furnace and antechamber, let's discuss this here. Sonochemistry is the use of ultrasound to enhance or alter chemical reactions. Sonochemistry, in the true sense of the term, occurs when ultrasound induces true chemical effects on the reaction system, such as forming free radicals which accelerate the reaction. However, ultrasound may have other mechanical effects on the reaction, such as increasing the surface area between the reactants, accelerating dissolution, and or renewing the surface of a solid reactant or catalyst. But this mechanism of operation to catalyze chemical reactions also has other effects, such as acoustic cavitation, a process that will be coming up again in the next episode. Furthermore, and I'll quote here from this article, Sonochemistry, uses of ultrasound in chemistry and related disciplines. The term sonochemistry is used to describe a subject that uses sound energy to affect chemical processes. This terminology is in keeping with that of the longer established methods that use light, i.e. photochemistry, and electricity, known as electrochemistry, to achieve chemical activation. It might be argued that a more accurate description of the subject would be cavitation chemistry, since the majority of applications rely on the energies generated by acoustic cavitation. However, sonochemistry is the established term, and certainly over the last few years, giant strides have been made in this subject. Gone are the days when sonochemistry was considered to be a, quote, black art, end quote, and simply a method of initiating intransigent reactions, particularly those that depend on the activation of metallic or solid reagents. Sonochemistry has moved a long way from its beginnings in the 1940s and 1950s through a renaissance in the 1970s to where it now stands as a major new technology available to scientists from a wide range of disciplines. Now, this so-called black art of sonochemistry is the reason my book series is entitled The Land of Chem, a play on words for the original name of Egypt and the etymological root word for our modern word chemistry. So I'll quote here, the word chemistry derives from the word alchemy, the ancient name of Egypt, chem meaning blackness, specifically regarding the rich dark soil of the Nile River Valley. Therefore, alchemy can be seen as the Egyptian art or the black art. Chemistry, from the ancient Egyptian word chemia, meaning transmutation of earth, is the science of matter at the atomic to molecular scale, dealing primarily with the collection of atoms, such as molecules, crystals, and metals. Sonochemistry and acoustic catalysts, using ultrasound to facilitate chemical reactions and process metals, is the black alchemical art of ancient Egypt. specifically in this case, regarding the function of the Great Pyramid for the production of a dilute sulfuric acid solution, whose primary application was metallurgical and mining operations. I also revealed how the configuration of the antechamber was engineered to allow the unidirectional flow only in one direction of the sulfur dioxide gas through these grooves, over the red granite slabs, and into the acoustic catalyst antechamber, a component that was designed to concentrate and amplify these ultrasound waves to catalyze the chemical reaction. And as the sulfur dioxide was being pulled through the system, producing sulfur trioxide, which was then dissolved into water within the contact process chamber, as demonstrated in the previous episode. It's a bit more complicated than that from the chemical reaction standpoint within the contact process chamber, which I'll be covering in the next video. So for now, let's just focus on the sulfur furnace and antechambers. Next, in episode 108, I presented a revolutionary paper that corroborates my hypothesis about the concentration of electric fields within the Egyptian pyramids, testing a variety of vectors from above, revealing the distribution of electric and magnetic fields within the Great Pyramid, specifically in the area surrounding the sulfur furnace and antechambers. A specific engineering design utilizing the geometry of the structure that was intended to focus these electric fields into these components to activate the inverse piezoelectric properties to produce the ultrasound catalyst. This system has nothing to do with utilizing electric current. It is all about the concentration and storage of electric fields within the dielectric. They also tested the vector from below, revealing both concentration of electric fields around the sulfur furnace and antechamber, but more importantly, these intense electric fields developing at the top of the pyramid. The experiment was also run on a bedrock substrate, testing the vector from above, showing distribution of the electric fields back into the limestone bedrock. And in episode 109, Electric Fields Inside the Great Pyramid Part 2, I explained how the telluric currents coming from below the Great Pyramid would induce the same electric field concentration at the top of the Great Pyramid that was experimentally proven when tested in the vector from below the structure, producing a concentration of positive charges at the apex of the structure. This is step one of the power source of the Egyptian pyramids, the telluric current charging from below the structure, resulting in positive field accumulation at the top, which served as the target for the negatively charged lightning strikes, inducing intensely concentrated electric fields within the area surrounding the sulfur furnace and antechamber to create the acoustic sonochemical catalyst reaction, further elaborated upon in episode 120, the Great Pyramid Ultrasound Catalyst, showing how lightning strikes would induce electric fields within the red granite components, dielectric materials that have the capacity for electric field storage, activating the inverse piezoelectric ultrasound waves and initiating the sonochemical reaction, essentially turning our reactor system on, where the ultrasound waves were concentrated within the acoustic catalyst antechamber, creating the desired sulfur oxides. This is exactly what we do today in our modern contact process, where the sulfur oxides are produced in a furnace chamber and then pulled through a catalyst component and then dissolved into the final product solution. Now, in members only episode 14, I explained how the parameters of the electromagnetic field concentration experiment could be changed to demonstrate the effects of low voltage telluric current charging from below, specifically with these shallow earth currents. And I'll quote here, A telluric current or earth current is an electric current that flows underground or through the sea, resulting from natural and human-induced causes. These currents have extremely low frequency and traverse large areas near or at Earth's surface. Earth's crust and mantle are hosts to telluric currents, with around 32 mechanisms generating them, primarily geomagnetically induced currents caused by changes in Earth's magnetic field due to solar wind's interactions with the magnetosphere or solar radiation's effect on the ionosphere. These currents exhibit diurnal patterns, flowing toward the sun during the day and toward the geomagnetic poles at night. And this is exactly what we have on the Giza Plateau. With the iron veins, as elaborated here, effects on shallow telluric currents can be found whenever a mineral has some remarkably different electrical conductivity compared with that of the surrounding materials. This gives rise to a localized conductivity anomaly. These iron veins pull the telluric currents directly up into the Great Pyramid, charging the structure with electric fields at the top to draw the initial lightning strike on the pyramid. And as above, so below, we could also modify the voltage from above in this experiment to match that of lightning, which would induce absolutely immense electric field concentration within the sulfur furnace and antechamber, and distribute excess voltage out through the iron veins. Remember that these two forces go hand in hand, and I'll quote here, "It is known that a significant part of telluric currents is caused by the excitation of the planet's magnetic field under the activation of solar activity, as well as lightning discharges occurring on the Earth during that current time. It is also known that every second on Earth, from 400 to 4,000 lightning strikes occur from raging about 2,000 thunderstorms, which excite pulsations of telluric currents within the Earth's crust." With the most important research article that I've ever found connecting telluric and Earth currents, lightning strike locations, and natural resource exploration, stating here, telluric currents are natural electric currents flowing in the Earth's crust and mantle. Lightning strikes balance telluric and ionosphere capacitance by bridging the lower atmosphere dielectric with static bursts. Most lightning comes from cumulonimbus clouds, which generate lightning. For cloud-to-ground lightning, the composite conductivity or resistivity of the rock matrix appears to have more influence on where cloud-to-ground lightning strikes occur. And based on numerous lightning data analyses, we have come to the conclusion that there are Earth currents, which we call terra levis, shallow Earth currents, in the depth range of natural resource exploration, and which have a controlling impact on cloud-to-ground lightning strike locations and attributes. This article says it all. There is a direct connection between telluric currents, lightning strike locations, and natural resources, such as metal or mineral deposits, exactly what we have on the Giza Plateau. All right, everyone, just a quick announcement. If you want to upgrade your members-only subscription and get 3 videos per month instead of just 1, check out the new Alchemist tier, now featuring an absolute banger 3-part series revealing the function of the Teotihuacan Pyramid Complex. Also, an unscripted, unedited Ask Me Anything video. We are now on AMA Part 4. Links to everything in the video description below to upgrade your membership. And thank you all so much for the continued support. Now, back to the video. All right, now let's put everything together in the animation, and I'll run the sequence up to where the reaction within the sulfur furnace begins. Let's go. All right, now here we have the sulfur oxide initial reactant being introduced into the sulfur furnace from the shaft below that was referenced in the previous episodes. The lightning strike at the top of the pyramid. Now, for the purpose of this animation, this bolt of lightning does not represent electrical current flow. This is the induction of electric fields within the pyramid as shown in the experiment. Remember, this system has nothing to do with electric current flow. It is all about the induced electric fields within the dielectric stone material, as shown in the experiment, with the electric field concentrating around these components, an intentional engineering design. These materials, limestone and granite, are dielectrics, the same type of material that we have in a capacitor. And I'll quote here, a capacitor works by storing electrical energy in an electric field created between two conductive plates separated by an insulator, or dielectric. When a voltage is applied, electrons flow from one plate to the other, creating a charge imbalance and storing energy. This stored energy can be released back into a circuit when needed, making capacitors useful for energy storage and voltage stabilization. Does any of this sound familiar? It certainly should. Thus, the applied voltage at the top of the pyramid, whether it has a flat top or capped with electrum, as some ancient texts suggest, it will induce an electric field in our stone dielectric material. This is a representation of the Great Pyramid, with lightning striking from above, the dielectric stone material of the core, and the iron veins, the discharge terminal. So these electric fields induced from lightning will surge into the sulfur furnace, passing through the relieving chambers, which concentrate the electric field directly into the sulfur furnace and antechamber. As the electric fields permeate the red granite material, activating the inverse piezoelectric effect and generating ultrasound vibrations, they are further amplified and concentrated into the acoustic catalyst antechamber. The water level is then lowered within the contact process chamber, pulling air into the sulfur furnace and drawing the converted sulfur oxides that have been reacted with oxygen from the initial sulfur oxide into the contact process chamber, the remainder of the sequence which have already been covered. So now I will run the whole thing from top to bottom so we can once again resurrect the Great Pyramid and bring this system back to life. Let's go. All right, in the next episode, we will proceed with the final reaction within the contact process chamber, utilizing that sonochemical acoustic cavitation that was mentioned earlier in the episode and the extraction chamber sequence. All right, everyone, that is it for today's video. This was episode 173, the full function of the Great Pyramid finally revealed. I really hope you enjoyed today's video, and if you did, subscribe to the Land of Chem here on YouTube. If you're interested in the technology of a lost civilization utilizing physics and chemistry, and the function of the Egyptian pyramids and other ancient structures from around the world. Remember to click that little notification bell so you don't miss out on new episodes. Like, comment, share, and stay tuned. If you want to help support the channel and get access to exclusive research content, check out the members-only channel and thelandofchem.com if you want to pick up a copy of the book or grab some merch, including the brand new Lightning Chemistry, absolutely gorgeous Japanese kanji calligraphy designed by my tattoo artist Shin from Funky Guns in Kobe. Now available at thelandofchem.com. Links to everything in the video description below. If you want to follow me on Instagram or on X, my handle is @thelandofchem. Also, don't forget, after you finish watching this video, please go subscribe to our 3 other channels. My wife Alexis' channel, Archeo Alchemy, our mutual travel, adventure, and culinary exploration channel, Let's Go with Lex and G, and the best channel on YouTube, Egyptian Trash Cats. For all you cat lovers out there, ladies and gentlemen, as always, thank you all so much for the support. I think that is it for today's episode. So I will see you next time. Yo, are you still watching this? Please subscribe to The Land of Chem here on YouTube and click that little notification button. New videos coming out every single week. And check out this other episode. Come on, do it. Do it now.